Good day, everyone. Today I'll be presenting my FYP presentation for the poster, and my topic is design and performance analysis of customized automated sprinkler system in Longhouse by using fire dynamic simulator. I am supervised in my FYP by Dr. Charlie Sia Chin Gun. For the introduction part, I'll start with research background. Sarawak Iwans are known for its longhouses architecture, which is long been used as a kind of rural habitation. Longhouses are unique to Iban culture. A longhouse may have a small group of tribe members or large number of extended families, and it may be the entire town. Nevertheless, they maintain their traditional way of life by building longhouses as dwelling spaces, despite changes in architecture and construction materials. Due to the longhouse's combustible material used to build it, it only makes it one of the most serious risks to fire. So Bomba Malaysia is looking for a fire safety aspect of longhouses, including installation of domestic fire sprinklers, which would help during a fire outbreak, especially the interior section. Next is problem statement. In Sarawak longhouses, fire is a constant hazard. The escape path, which is largely reliant on home architecture and layout, is one of the most important aspects in fire protection. Longhouses has resulted in one fatality and more than 10 million ringgit losses so far in 2019. Other than that, longhouses in this research has limited amount of availability of water, which makes it even harder for them to put out any fire incident. Longhouses is located in rural areas, which is out of reach from firefighters to come and assist if there's any fire incident. Due to the limited availability of electricity and water, a customized automatic sprinkler system is recommended to be designed accordingly to the situation of longhouses and cost effectiveness. This research aims to design a customized fire sprinkler system for the traditional longhouses with limited water and electrical resources and cost effective by using fire dynamic simulator. The research objective is to analyze and perform FDS to solve real-world fire challenges in fire protection engineering, while also serving as a research tool for fundamental fire dynamics and combustion. Other than that, is to study and determine the most suitable customized fire sprinkler design that cost-effective and works perfectly well with the limited electricity and water. The scope of the study is mostly on a computational fluid dynamics model of fire-driven fluid flow. Is the fire dynamics simulator (FDS) to explain the evolution of fire. The computer software numerically solve a large eddy simulations variant of the Navier-Stokes equation suited for low speed, thermal-driven flow, and emphasis on smoke and heat transfer from flames. Through this simulation, we can study the properties of smoke, heat transfer, and in longhouses fire, where the result can assist with the design of fire sprinkler. Next is research questions. How does a customized fire sprinkler can be effective in putting out fire in longhouses and cost effective at the same time? And then that is how to overcome a lack of electricity and water in longhouses in order to implement fire sprinkler in longhouses. Next is the lecture review. First is the customized fire sprinkler and smoke detector. Fire sprinkler is not activated by smoke, contrary to the common assumption, because heat transferred upward by smoke from a fire. It's a simple error to make. However, if smoke was the source of fire, just tossing the kitchen, the office and kitchen may be enough to saturate the area with what the fire sprinkler had. Fire sprinkler operate because they are activated by tremendous heat. It has come to the decision in this research where regular residential fire, so fire sprinkler will not be ideal for this research due to the combustibility from its material used to build the longhouse. In this research, smoke detector is an electronic fire protection equipment that detects presence of smoke. Other than that, the smoke detector will be customized where it will detect smoke and directly will activate the fire sprinkler instead of just sounding the alarm. And for the fire sprinkler nozzle, due to the limited electricity, water resource, a customized fire sprinkler nozzle is proposed, where the mechanism is such like automated garden water sprinkler nozzle head is proposed because of its adjustable properties. With the adjustable properties, we can control how the size of the sprinkler exert water out in a bigger and suitable dimension that not only could cover the desired area but also use less water pressure. So when the smoke detector detects the smoke, it will activate directly the fire sprinkler. In this particular way, the fire sprinkler system design is very much efficient and effective in handling fire threats or situations in longhouses due to the extremely combustible hardwood materials. Smoke detectors respond faster than residential and conventional sprinklers, according to all the studies, and thus provide the earliest warning of a fire to building inhabitants. Next is the dynamic simulator, fire dynamic simulator. The study uses fire dynamics modeling to investigate capabilities of automated sprinkler system. The scenarios were chosen based on FPA 101, a longhouse is composed of hardwood material that may burn in Class A fire. The conflagration in this exact scenario is simulated to analyze the heat and smoke created if there's any fire in the longhouses, as well as its effectiveness of the automatic sprinkler system in extinguishing fire. This program can anticipate smoke motions, hot air flow from fire, and elements such as wind, ventilation, and other consideration. Next, I'll be talking about the methodology. So, to have a fire sprinkler in the longhouses, we need water supply. So where do we get it, and how do we transfer it? So that is where a submersible pump will come in. So the main water supply for the fire sprinkler in the longhouse will be the river nearby. A submersible pump is recommended because it's a hermetically sealed motor that is tightly connected to the pump body, and the whole system is immersed in the pump fluid. The major benefits of this pump is that it eliminates the pump cavitation, which is a problem caused by large elevation difference between the pump and the fluid surface. The submersible pump will be powered by solar energy panel. So next, I'll be talking about solar energy panel. By using solar panels, we can use less energy and less money. So the main function of solar panel is providing electricity to current to the submersible pump. We will pump the river water to the electric tank, where we store the collected water. People in these rural regions searching for long-lasting and dependable economical energy sources. This is where solar comes in. Open expanses, more green areas, animals, cattle, and farms operated in rural regions. So what is the best solar panel for rural areas location, mostly for longhouses? So it must be wind resistance. Its value indicates that solar panels' capacity to endure wind pressure. Other than that, it works very well with when dust and dried leaf collects or on the panel surface. Thirdly is the ammonia resistance, and fourth is the salt and mist resistance. Due to the moisture and content in the air, solar panels put near water tend to deteriorate faster. And lastly, the most important part of this methodology is the elevated tank, where water tanks are elevated overhead for water supply. Pumps are only required for pumping until the tank is filled, when water must be pushed to distribution system at high ends without needs of pump supplies. Elevated tank do not require constant pump operation since the pressure is maintained by gravity, which has no effect on the distribution system. In short, it is recommended not only due to not using electric energy, but also it is cost effective, perfect for long houses. Water pressure flow will be proportional to the height of the elevator tank. The taller it is, the higher the water pressure. Lastly will be the fire sprinkler nozzle, working together with the smoke detector, as I talked before. So the fire sprinkler must be a customized one, similar to an automatic garden water supply nozzle, because the sprinkler exits water out in larger and more stable dimension with adjustable sprinkler nozzle, which not only covers the only area, but also use less water pressure. So this is the the last part of the system. So smoke detects the smoke, it will activate directly the fire sprinkler, and fire sprinkler will exert all the water that is required to put out fire. Lastly, my future plans for this project is to go to longhouses to get the proper data, to see the situation where the fire could start, and also to get the data from the simulations of FPS that could help me. Thank you very much. That's it for today for my presentation. Thank you.